proceed here. So as you know that last class we discussed what is distillation and what is the separation technique of distillation, how we can obtain the drinking water or pure water from the salt water. That is the plants which we used to call as desalination plants, we can say. So most of the less rain countries, like less rainfall, the countries like no rain or little rain, what is that countries we used to call it as? Hot and arid countries. So they will use a desalination plants to extract the water, distilled water from the ocean or sea water. Later they will add the required minerals for the water to use it as a drinking water. Because pure water, is it good for health or bad for health? Is it possible to drink the pure water? Yes, please. All of you.
Bad for health.
Bad, because does not contain any minerals and all. So it is not suggested to drink the distilled water or purified water, which is directly from the desalination plants. So always we people used to prefer by adding after mineral added water only we used to drink. Now, as I told you, if you want to use the distillation technique, so what kind of mixtures we can separate? I told you two kinds of mixtures we can use to separate with the help of distillation. What is the technique? Anybody can tell me? What is the mixtures, Mitakshri? So first thing, yes, please. If you want
solid and liquid.
Yes. A soluble solid is dissolved in what? A soluble
Liquid.
solid is dissolved in liquid. Then we can separate the liquid and solid both at a time with the help of distillation. Is it yes or no, guys? Yes, please. So what is the principle here? Anybody can tell me? Harish, Gokul, what is the principle? What is the principle behind this distillation? Evaporation and as well as followed by what?
Condensation.
Yes, please. Evaporation followed by what?
Condensation.
Followed by condensation. So that is only the principle of distillation. Understand, Mr. Reddy? So if we'll take a soluble solid is dissolved in liquid. So what we people take example, obtaining the water from the salt and water from the sea water. So we'll take sea water in some kind of flask. What is that flask called as? What is that flask called as?
Distillation flask.
Distillation flask. Understand? So that we people will start heating. You can see here, this is what the diagram which we already studied in last class also. So we'll take the salt water, that is what mixture of salt solution in a distillation flask. So we'll started heating. So what is happening? Salt will be stuck in this distillation flask only, but water will keep on evaporating. That is what it will form the water vapor, which is known as what? Steam. Understand? So this steam will rise us up and it will be passes through the one kind of tube. What is the tube called as?
Water condenser.
Water condenser. So once the fumes are passing through this water condenser, so there will be temperature is reduced and it will be condensed back into what state? Condensed back into pure water. That is what liquid state. So this is what the technique we'll use. First we are evaporating. So what is the technique of, what is the principle behind? So evaporation followed by immediately what? Immediately condensation. So condensation means, evaporation means what? Converting liquid state into gaseous state, and again condensation means what? Gaseous state into liquid state. So this is only the working principle of distillation. I understand, Mr. Johan, Mitakshri. So this is what we used to call as distillation. Now if you notice this distillation, also we can call it as simple distillation. What we used to call? Simple distillation. Okay, everybody. So distillation or simple distillation. Now, is it only we can use it for soluble solid in liquid, or else we can use it for any other things? Mitakshri, Harish, Try to answer, please. Don't be silent.
Liquid in liquid.
Yes,
Sir, liquid in liquid.
liquid in liquid, but their boiling point differences must be, remember, more than 25 degrees Celsius or 25 kelvins. When we can use this one, minimum the boiling point difference between how much? How much? Minimum 25 degrees Celsius or 25 kelvins above, then only it is possible to use the distillation or simple distillation technique. Are you clear, Hari? Everybody? Please respond. So, when we can use that one? When you are taking a mixture of two immiscible or miscible liquids, whatever it is. So, if you take, so separation of mixture of two or more liquids, miscible and immiscible liquids, doesn't matter. So, the liquids which mix together in all proportions or not at all mixing, doesn't matter. So we can separate it. Observe very carefully. So if it is immiscible, we can use a simple technique. What is a simple technique we can use? Anybody? If it is immiscible,
Filter.
please.
Separating funnel.
Separating funnel. That is what it is. So we can use distillation for second one. Miscible or immiscible liquids? Everybody. Miscible or immiscible? Miscible only. M-I-S-C-I-B-L-E. M-I-S-C-I-B-L-E. Miscible liquids. But their boiling point difference must be how much?
25 degrees.
Yes, please. Their boiling point difference must be how much? Greater than 20, understanding, 25 degrees Celsius, or we can say 25 kelvins. Is it okay, Hari? Ready?
Yes, sir.
Yes, that is. So, suppose if it is less than that, is it possible to find it? Is it possible to separate it? That is what my question. Anybody? If it is less than that, is it possible to find it? No. Why it is not possible? That is what my question. Let me think and answer. Who will answer? If it is boiling point is less than that, what will happen? Why it is not possible to separate?
Both will
We
evaporate.
can use fractional distillation.
Yes, not fractional distillation. Observe, Mr. Akilan. So what is the minimum temperature I said? Your textbook, it has been given 25 Kelvin. So 25 Kelvin also is equals to what? 25 degrees Celsius. It's not equals to difference I am saying. You understand, Mr. Hari? Everybody, difference I am saying. Understand, Amma? For example, see, one substance temperature is 10 degrees Celsius. Another temperature is 50 degrees Celsius. Now, if we'll add plus 273, what will come here? 283 Kelvin plus 273, which is equals how much, Hari? Fastly. Ready? What happened? No response at all, Johan and all. I don't know what you people are doing. Tell me fastly. 273. How much, Mitaksri?
323, sir.
323. Now, notice it. What is the difference between degrees Celsius? 10 and 50. 50 minus 10. How much it is? 40.
40.
Same way, Kelvins verify. 323 minus 283. How much it is? Yes, please. 323 minus 283, which is equals to also what?
40, sir.
40. Have you noticed the difference is same? Understand, everybody? Yes, please. Yes or no?
Yes, sir.
Yes,
So,
sir.
I can take in degrees Celsius or I can take in kelvins. Both are same. So what is the difference minimum? The boiling point's temperature must be minimum how much? Boiling point's temperature minimum greater than more than 25 degrees Celsius or 25 Kelvin. Please remember, it's very, very important. So if miscible liquids having, understand, greater than 25 degree Kelvin, sorry, degree Celsius or 25 Kelvins, then we can go with which technique? We can go with the simple distillation. Very simple distillation. Or we can go with the distillation technique. Understand? Greater than. Understand? If it is less than, we can go with the fractional distillation. Are you understand, everybody? So observe very carefully. Why means, so as we know, this is what the distillation flask. If the temperature difference is very closer, So it is very difficult to maintain the temperature. Are you understand everybody? With the help of thermometer, so when we are heating, if the boiling point difference is greater than 25 kelvins, so that we can maintain the temperature here very easily, so that only one liquid will evaporate, another liquid will be keep on boiling here only. Are you understand, Amma? Yes, please. Nobody will answer. Yes. So that is what. So if it is less than 25 kelvins, the boiling point difference, then it is very difficult to maintain the temperature here, so that if one liquid will evaporate, at a time the second liquid also will evaporate, because temperature difference is very closer. So again in the condenser tube, again both liquids will obtain. Is it yes or no? Everybody? Yes, please. Both liquids obtain. So that is why we will never use a simple distillation if the boiling point difference is how much, guys? Boiling point difference is how much? Nobody.
Less than 25.
Less than 25 Kelvin. So when we can use simple distillation, the boiling point difference is
More than 25.
More than 25.
more than 25 kelvins or 25 degrees Celsius, then we can use the simple distillation to separate the miscible liquids. If not, we people will go with the second type of distillation technique. So that is only what we used to call fractional distillation. Okay, everyone. Shall we start now? Fractional distillation.
Yes, sir.
Yes. Now, what is the principle of distillation? Anybody can tell me what is the working principle of distillation? Mitakshri, Harini, Arun Kailash.
Sir, evaporation and condensation.
Evaporation followed by
Condensation.
condensation. That is only the principle of distillation or fractional distillation. So, first of all, everybody should answer. When we can use distillation technique? Two cases. One is a soluble solid is dissolved in what? Liquid. We can use distillation to obtain the both solid as well as liquid. Or else are two miscible liquids, but their boiling point difference is how much? Two miscible,
More than 25.
but the boiling point difference is must be more than how much? Or greater than 25 degrees Celsius or 25 Kelvin. Is it okay, guys? Yes, please.
Yes, sir.
Yes. Now, if you want to separate, that is what? If you want to separate two or more immiscible liquids, two or more miscible liquids. Ready? What happened to you, ready? Miscible liquids, but their boiling point difference is less than or greater than? Yes, please. But their boiling point difference is less than or greater than? Less than 25 Kelvin. Then we can use which technique, guys? Then we can use fractional distillation. Fractional distillation. That is what it will be happening. Are you clear, everybody? Yes, please. Now, if you want to understand the fractional distillation, I want to say you one real life example. Now, observe very carefully. It is not a big deal at all, but looks very complicated, but it is very, very simple. Now, your mother will give you one glass of tea. All of you observe very carefully. Your mother given a very hot tea or one glass of tea. It's okay, ready. Now, your mother has given one glass of tea to you. Now, she will ask you to consume within 1 minute. So, how you people will consume? It is very, very hot. So, you want to take it very fastly. So, what is the possibility of taking the tea? Anybody can tell me?
Cool is temperature.
How you will take, Mr. Reddy, Mr. Gokul, everybody, Divya? Try to answer.
Cool is temperature.
Yeah, how you will cool? If you keep in cup, it will take more time to cool. So what you people will do?
So it transferring the tea into a large surface area, sir.
Yes, very good. That is what it is. So if the tea is in glass, it will take much time to become cool. Is it yes or no? Everybody try to answer. Yes or no, Mr. Johan? Not interested, please leave from the meeting. No issues. Try to answer. If the same tea is in the glass, it will take much time to cool down. But have you noticed it? Movies and all you might be watch. The person who wants to take the tea fastly, the person will pour in the saucer and they will sip very fastly. Yes or no, Mitakshri? Why it will be
Yes,
very
sir.
fastly? If you pour the tea in the saucer, the tea will become very fastly. It will become cool very fastly. Why it is? Anybody?
So because evaporation increases on surface.
Yes. The exposed surface area is more faster, so that the temperature will fall very fastly. Yes or no, guys? Yes, please. So contact area. So more body will contact, so that air is contacting more, so that more heat energy will be taken away by the air, so that more fastly the temperature will fall. Yes or no, Mr. Arun? Yes. So that is the same principle we are using here in the fractional distillation also. Basically, distillation, we are having only one distillation flask. Now, above this distillation flask, we can arrange one fractional column which contains the marbles. Marbles means you might be knows. Glass marbles. Do all people know or not? Don't know? Glass marbles will be present. So, glass marbles is present means surface area increasing or decreasing? Everybody? Surface area increasing or decreasing? Yes, please. Nobody will answer. Surface area increases or decreases? See, from cup to saucer, if I'll pour the tea, surface area increases or decreases?
Increases.
Surface
Increases.
area decreases. Occupied area, Mitakshri. Tea is occupying more area or less area now compared to cup to saucer?
More areas, sir.
More area. So that is why the temperature falling very fastly. Yes or no?
Yes, sir.
Same way, if I use the fractional column contains marbles. So when the gas fumes are passing through that marbles, is this marbles will absorb the heat energy or not? That is what my question. Is they will absorb the heat energy or not? Can you understand my question? When the gas fumes are passing through these marbles, is it that will absorb the heat energy or not? That is what my question. Okay, you cannot understand the question, everybody? Please, yes or no? At least say yes or no so that I will ask.
Yes, sir.
Now, when we can use the fractional distillation, everybody tell me, when we can use fractional distillation?
So when the temperature is less than 25 Kelvin.
Yeah, boiling point, not temperature. The boiling point difference is less than 25 degrees Celsius or 25 Kelvin. We'll go with the fractional distillation. Are you clear with that point, everybody?
Okay.
Yes? All of you please respond.
Yes, sir.
Now, for example, let me take alcohol and water mixture. What is the water boiling point? Anybody can tell me? What is the water boiling point? Yes.
100 degrees Celsius.
100 degrees Celsius. Very good. What is the boiling point of alcohol? Alcohol is 78 degrees Celsius. Alcohol is how much? 78 degrees. And what is the water? What is the water, ma? 100 degrees Celsius. So what is the difference? What is the difference? Anybody? Difference in temperatures. 100 minus 78. What is that?
22.
22. So is it less than 25 or greater than 25?
Less than 25.
Less than 20.
25 degrees. So we can use which technique? Fractional distillation or distillation?
Fractional.
We can use fractional distillation. Understand, it is very, very important concept. Fractional distillation. Now, who will evaporate first? If I will start heating, who will evaporate first? Alcohol or water? Alcohol or water? Alcohol. Understand? So alcohol, what is the boiling point of alcohol?
78.
78 degrees
Point of alcohol. Everybody.
78 degrees Celsius.
Yes. Understand, everyone? Now, observe very carefully. Fractional distillation and distillation, only difference is this fractionating column. Have you noticed it? Extra, I am keeping only this fractionating column, which is packed with the what beads? which is packed with what? Glass beads. Are you understand, everyone? So that is the only difference between fractional distillation and as well as simple distillation. So simple distillation, there is no kind of this kind of glass beads. Yes or no, guys? Please respond. Yes.
Yes,
Yes. So what will happen? Directly the gas will evaporate and it will be condensing, passing through the condenser, so that it will be getting back into the liquid state. That is what will happen. Now, if the temperature difference is less than 25 degrees Celsius, now you can see, guys, if I am started heating, who will evaporate first? Who will evaporate first, guys?
Alcohol.
Alcohol
Alcohol.
will evaporate first. But alcohol temperature is how much, guys? Boiling point 78 degrees Celsius. Now, if I am trying to evaporate complete alcohol, by that time the temperature will increases to 100 or not? By that time the temperature will reaches to 100 or not? Yes or no? Please respond. 78 to 78 degrees alcohol will evaporate. Is it okay, guys? Yes,
Yes,
please.
sir.
Or understand, Hari? Evaporate. Now, if I am trying to heat continuously, so 78 to 100, fastly the temperature will reaches. Is it yes or no?
Yes, sir.
Yes. So once, if alcohol will reaches to the 78 degrees, it will start evaporating. Is it completely will evaporate or only it will begins the evaporation?
Begins the evaporation.
Begins the evaporation. So now, by the time if the temperature reaches to 100 degrees Celsius, water also will start evaporating. Is it yes or no?
Yes, sir.
Yes. All of you understand or not? Mitaksri, please respond. Evaporate. So that both water and alcohol again will come back and both we can collect here. Is it what we want? Is it what we want?
No, sir.
No. So what we
No.
want? What we want? We want to separate alcohol and water. So that is why we are using a separate column called as, what is the separate column? It is called as fractionating column, which is packed with the glass beads. Which is packed with the what? Glass beads. Now, what will happen here? I will explain you. Observe very carefully. It's very simple if you'll understand. Like same way like cup and saucer. Cup and saucer. If you'll pour the tea in cup into the saucer, so exposed surface area is more. So that more fastly temperature will falls. Yes or no, guys? Yes or no?
Yes, correct.
Yes, sir.
Now, observe very carefully. When I keep on heating, so first who will evaporate? Who will evaporate?
Alcohol.
Alcohol will evaporate. So, alcohol, you can see the gaseous alcohol having a temperature of how much? Before entering into the glass beads. Before entering into the glass beads, how much temperature?
80 degrees
80.
Celsius.
80 degrees Celsius. Now, suppose you are having a 80 degrees Celsius now. The gas is passing through all the particles. Is it all the particles will take the heat energy or not? Yes or no? Yes or no? When the gases is passing through these glass beads, for example, this is the glass bead. Now gas is forming like this. Now, if it will come on contact, so that the glass beads will absorb the heat energy or not? Yes or no? That is what my question. Yes,
sir.
please. Yes,
sir.
because surface area increasing or not? Surface area increasing or not? Because of more glass beads. So whenever the gas fumes are passing through these glass beads across every glass bead, so the glass beads will absorb the heat energy. So again, temperature will decrease or increases. You can see here when the gas fumes are going up, temperature is decreases or increases?
Decreases.
Decreases.
Temperature decreases. See here, down it is 80, but next level what is there? Next level what is there?
79.
79. Up what is there next? When it is reaches to the top of the fractionating column, what is the temperature? 70.
70.
Understand? So 78 degrees, still alcohol in what state? Gaseous state or liquid state? 78 degrees. Still it will be
Gaseous.
vapor state only. So they will pass through this condenser and alcohol will be collecting as a separate beaker. But the temperature will never rises to more than, understanding, 78 degrees Celsius because of here fractionating column. So water, is it possible to form the water vapors? Is it possible
No,
to form
sir.
the water vapors? No. So
No,
water
sir.
will keep on boiling, but water will never evaporate. Only who will evaporate? Who will evaporate?
Alcohol.
Alcohol alone will evaporate. So that is what fractionating column. So what is the fractionating column? So fractionating column, this is what glass beads. Are you understand everyone? Now see, imagine this is what the glass beads. Now, if it is empty space, directly, this is the cylinder. If it is empty space, directly the gas fumes will go like this. Is it yes or no? Is it
Yes,
yes or no? So that the temperature will rises very fastly. But when the same gas fumes are passing through this glass marbles or glass beetles, so that whenever they will come contact with that, they will the glass beetles will absorb the heat energy, so that the temperature of the gas will decreases. Is it yes or no? Yes.
yes, sir.
Yes. So that is why you can see the alcohol fumes are rising up. The temperature is again decreasing 80 to 79, 79 to 78. At 78, still the alcohol is in what state? 78 degrees Celsius, alcohol still in what state?
Gaseous.
Gaseous state. So from there, the vapors will pass through the condenser and they will be collected in the beaker as a liquid state. Is it okay, guys? Everybody? So this is only called as fractional distillation. So we are using the glass beads here only for one purpose. What is the reason? Anybody? What is the reason? Mr. Gokul, Harini, Kaushik? What is the reason? To increase the surface area and also to not to rise the temperature. So glass beetles, if the surface area is increases, then what will happen? It will absorb the heat energy so that it will cause us to fall in temperature. Are you understand, guys? Please respond, guys.
Sir,
Yes, ask me, Hari.
so why you have to lower the temperature, sir?
Because if you are not lowering the temperature, for example, see, Hari, if you are keep on increasing the temperature, now this alcohol, see, for example, if I'll remove this fractional distillation, alcohol is evaporating by 78 or 80 degrees Celsius, but complete alcohol won't evaporate. Yes or no?
Yes, sir.
Yes. So now slowly alcohol fumes are started rising, but by the time keep on heating, by the time temperature reaches to 100 degrees also. Yes or no?
Yes, sir.
At that point, water also will evaporate. Yes or no, Hari?
Yes, sir.
So we cannot separate the mixture. That is why temperature should not be rises. Are you understand? Even though we are heating, temperature will never go behind it. So that temperature will be cooling only. Are you understand?
Yes, sir.
That is what will happen. Is it okay, Mitakshri? Divya, have you understand?
Sir.
Respond, please. Everybody. Now, for example, ask me, ready. Now, I have one important question I will ask you. Let me see who will answer. Now, if water boiling point is less than 100 degrees, what is the state of water? Liquid or gaseous state? Liquid or gaseous state? If water temperature is less than 100 degrees, liquid state or gaseous state? That is what my question.
Liquid.
Liquid
Liquid
state.
state.
Now, for example, Mr. Arun Kailash heated here more than 100 degrees Celsius. How much he has heated? How much he is heated? He's heated more than 100 degrees Celsius, so that water also will evaporate. Yes or no?
Yes, sir.
Water also will evaporate. But when it is going up, the fractional distillation temperature will falls into what again? Less than 100 degrees Celsius. How much it will fall? How much it will fall?
Less than
Than 100 degrees Celsius. So if the temperature less than 100 means, see, when the water is in beaker, the water temperature is 100 degrees, so that it will form the gaseous state. Once it will come to the fractional distillation, temperature falls less than 100 degrees. So that again water will condense back into which state?
liquid.
Condense back into which state? Liquid state. So that again it will fall back into the distillation column. Understand, Mr. Gokul, what I am saying?
Yes, sir.
Understand, Hari? Even though water will evaporate also, but again it will be condensed back and it will be fall into the same distillation flask only. Are you clear, Mitakshri?
Yes, sir.
But alcohol at what temperature it is in gaseous state? 78 degrees. So till 78 degrees Celsius, it is vapor state only, so that the vapors will come through the condenser and we can separate it separately in a separate beaker. Is it okay, guys?
Yes, sir.
Yes.
Have you understand? So this is very important. So even though the temperature is rises, but still when it is going up, it will be condensed back into the same distillation flask. Which one? Water, so that only alcohol will evaporate. So that is the importance of fractionating column. So we can separate the fractionating column. We can use to only for one purpose. What is the purpose? To increase the surface area so that the temperature of the vapors will cool down, so that automatically that the substances which is having understanding at the high boiling points, they will condense back and they will fall into the same distillation flask back. So that is what fractionating column we can say. Are you clear? How many of you understand this one, fractional distillation? Yes, please.
Yes, sir.
We can use the fractional distillation to separate the two miscible liquids, two or more miscible liquids, but their boiling point difference is how much? Their boiling point difference is how much? Yes, please. Boiling point difference is how much? Less than
25 Kelvin or 25 degrees Celsius.
25 Kelvin or less than 25 degrees Celsius. Is it okay, guys? Have you understand or not? Please respond. Yes, Amma?
Yes, sir.
Yes, sir.
That is what.
Yes.
This is what we used to call fractional distillation. A mixture of alcohol and water. We can separate even alcohol, or you can take ethanol and water. We can use to separate by using separation technique called as fractional distillation. Is it okay, guys? Everybody? Yes? That is what.
Yes.
Now, if you'll understand this fractional distillation, now I want to separate two immiscible liquids. Then which technique I can go, guys? Anybody? Two immiscible liquids.
Separating.
Yes,
Separating funnel.
separating funnel. So immiscible liquids. Immiscible liquids means what? What is the example? Anybody can give? Example
Oil
of
and water.
immiscible liquids. Oil and water. Oil and water. Okay. So like immiscible liquids, if you want to separate two or more, doesn't matter. We'll go with the separating funnel. What is the name called as? Separating funnel is a separation technique to separate more than two or more than two immiscible liquids. So here, the working principle of separating funnel is understanding based on density. What is that? Yes, please. Based on density of a liquid, we people can separate it. Which liquid will come first? Which liquid will come next? So you all people know separating funnel. So separating funnel we can use to separate which liquids, guys? Which liquids? Yes, please.
Immiscible liquid.
Immiscible liquids. So two or more immiscible liquids are there. Then we can use a separating funnel. So in our textbook page number 20, you'll be having a separating funnel diagram also. You might have noticed everything. So they're using the separating funnel to separate the kerosene and water. Have you noticed it, everybody? Yes, please see that.
Yes, sir.
Yes. So that is what we used to call as separating funnel. So observe very carefully. Separating funnel will work with a phenomena called as based upon what? Based upon
Density.
density of
Density.
liquids. Density of a liquids. Now, if you'll notice it here, we are using to separate oil and water mixture. So what is the oil they have taken here? What is the oil they have taken? Kerosene.
Kerosene.
And what is the water? Water. Now, who is it down? Water or oil?
Water.
Water. So who is more denser? Water or oil?
Water.
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 The density of water is understanding more denser than kerosene. So that is why high density particles will be down and low density particles will be up. So how we can separate it means now. So this is what we used to call as stopcock. What we used to call? Stopcock. Understand? Now I want to separate the water. So I will take one empty beaker. Now slowly I will release this stopcock so that till where means I have to notice that entire water will drain out into this beaker, and almost you can see the corrosion layer will reaches to the stopcock. Almost, you should not keep fully also. Almost it will reaches to the stopcock. Which layer? Corrosion layer. Then you can again close the stopcock and remove this water side. Understand everybody? Then water will be separated. Now, again you want to get the corrosion back. Understand? Then we should not keep the beaker directly. We have to release the stopcock and 2-3 drops, it has to be fall down. Understand, Mr. Reddy? Hurry. 2-3 drops need to fall down. Later only you can take the beaker and you can collect the remaining corrosion into the another beaker. Understand, Mitakshri, Divya, everybody? So like that. Why we should leave 2-3 drops into the ground? Anybody can answer? Why we should not collect the beginning? Yes, please. Because that may contains some drops of water. So that is why if you want to separate perfectly, then 2-3 drops of initially we have to leave it to the down soil, so that whatever the water droplets are present, they will fall down. Later you can collect into the another beaker. That is what we can get the corrosion separately. So this is what the separation technique which we used to called as. What is the separation technique called as? Separating funnel. Understand everybody? So which we can use it for what? Miscible or immiscible? Miscible or immiscible, guys? Immiscible. Understand? 2 or more immiscible liquids will use this separation technique called as separating funnel. Understand? So if it is miscible liquids, which technique we can use? Miscible liquids means
Distillation.
fractional distillation. Understand? Miscible liquids means fractional distillation, but its boiling point difference is how much? Boiling point difference is, understand how much, Amma? Less than 25 Kelvin, fractional distillation. Greater than 25 Kelvin, we can go with what?